This is the answer to the Algebra 1 test on coordinate plane, functions, graphing with table, graphing with intercepts. Question number 1 says to use the graph on the right to answer the questions. Plot these points. Identify the quadrant of each of these points. So number 1 is -2, -3, which is to left 2, down 3. That would be point P. Q is to the right 1, up, down 0. That's point Q. R is 0, up 3. A lot of students will do that one incorrect. And S is to the right 4, up 1, 2, 3, 4, 5. That's S. In which quadrant is each? P is in quadrant 3. Q is in none, because it's on the x-axis, so you can say none or x-axis. R is also none, you can say none on the y-axis. And S is in the first quadrant. B, for the same question, says to identify the coordinates of A, B, and C, and identify the quadrants. So A is right here, which is to the left 1, 2, 3, 1, 2, 3, 4. Looking at the dot, not the letter. So to the left 3, down 4, that's quadrant 3. B is 0, so it goes left, right, 0, then down 1, 2, 3, 4, down 4, and again that's none or exactly on the y-axis. And C is to the left 2, then up 1, 2, 3, 4, and that's quadrant 2. Question number 2 says to determine whether the relations below are functions or not. So function, yes or no, and then decide on how you make your choice. So this one, -4, 0, 4, and 1. So I would say yes, no. Yes, it is a function. Why? I would say each input has one output. For B, is B a function? The answer is definitively no for that one. The reason it's not is for 2 reasons. 4 has no input, 4 has an input but no output. 3 is an input, has no output. And 5 is an input and it has 3 outputs. So for multiple reasons it's not. You could have said the input of 5 has 3 outputs. Each input should have 1 output. So the input of 5 has 3 outputs, and 4 and 3 have no outputs. Each input needs to have exactly 1. This has 1 and this has 1, but that has none, none, and 3. C. Is C a function? The answer is yes. Each input, x's, has 1, 1, 1 arrow coming out of each of them. Yes, they tend to be going into the same one, but each of them have exactly 1 coming out of them. So yes, again, each input has 1 output. Same as the purple example. And D, is this a function? The answer is no, because it fails the vertical line test. Here it hits my vertical line more than once, so it fails my vertical line test. It is not a function. Moving on to 3, given the functions below, find the range given their domain. Well, if the range is the y's, the domain is the x's. So saying if these are my x's, I just plug these in for x and figure out what my y's are. So what I can simply do is make a table, x, y equals -3x plus 2, and fill in my x's, -3, -2, 0, 1, and 4. And then I would plug in -3 times -3 plus 2, then -3 times -2 plus 2, and I'll do the rest. Once I have them all plugged in, I just have to do my order of operations to correctly get my y. Negative times negative is positive 9, 9 plus 2 is 11. Negative times -2 is positive 6, 6 plus 2 is 8. -3 times 0, that's the multiplicative property of 0, that's 0 plus 2 is 2. -3 times 1, that's the multiplicative identity, multiplied by 1 stay the same. So it's -3 plus 2 or -1. -3 times -4 is -12, -12 plus 2 is -10. So these would be my range or my outputs. I will do the same thing for B and make my table with B, except this time my domain, my x's are -4, -2, 0, 1, and 6. My equation is y equals 1/2 x minus 3, and I'll plug into this table, give myself a bit more space. I'll plug in each of these. equals 1/2 using parentheses of 4 minus 3. And I would plug in for the rest of them. And I'll do that so that when I do this work, I get my y. 1/2 of -4 is -2. -2 minus 3 is -5. 1/2 of -2 is -1. -1 minus 3 is -4. 1/2 of 0 is 0. That's the multiplicative property of 0. 1/2 of 0 is 0 minus 3 is -3. 1/2 of 1 is 0.5. That's the multiplicative identity, 1/2. 1/2 minus 3 is -2.5. And then 1/2 of 6 is 3. 3 minus 3 is 0. So this is my range given my domain that they gave us. Question 4 asks us to first determine if it's a function. If it is a function, then find the domain. Oh, it doesn't matter if it's a function or not. Then find the domain and range for each and set builder notation. So let's determine if they're functions first. Is this a function? No. It fails the vertical line test. Is this a function? If I go across, there's no line that passes more than 1, so yes, it is a function. Is this one a function? The answer is, again, no, because it failed my vertical line test. Is this a function? Doesn't look like it, but there's no spot above each other. The answer is yes, it is a function. All right, let's talk about the domain. Domain, as we know, is all of our x's. The domains are x's. Let's go left to right. So we write our domain, we write in set builder notation. So all the x's such that we always eat to our right. Again, for our domain, it's all the x's such that we always eat to our right. Domain is all the x's such that we always eat to our right. But I'll do that in a second so that we can get some practice. Let's do this one. The domain. This, as we eat to our right, the reason we make these open parentheses to the right is that way the opening is to the right, is that way we know that this is how far left it goes and this is how far right it goes. We can simply do that. Some students like to do a highlighter and sort of draw lines. How far left does this go? Well, it goes all the way to the left to 0. How far right does it go? Well, there's no restriction, so it goes forever. So since it goes to the right forever, what I can do is I can erase this side, get rid of that L, and close it all up, and it looks like that. Again, this is left and this is right. If we open them up this way, then we know this is left and that's right. This goes to the left forever, so there's no restriction. I'll erase that. This one goes to the right forever, so there's also no restriction there, so you can just sort of tighten it up. There's no restrictions in either direction. Let's continue doing my same thought process. The domain is all the x's such that we always eat to our right. The opening is always to the right. What we can do now is we know that this is how far to the left. Well, how far left does this graph go? Again, some people like to draw a little highlighter. This goes to the left 1, 2, 3, 4, -5. Is there a line underneath? Is it included? Is it not included? Not quite sure. It's hard to tell. If you want to draw a line underneath, it's okay. You can. We have no evidence either way. If you were to put that or you were not to put that, it would end up being okay. I'll leave it there. All right, let's see. This represents how far to the right. How far to the right does this go? Let me draw it a little bit better. This goes to 0. Now this time we do know because it's an open circle and an open circle. Since it's an open circle, it is not included. So if you draw that line, that'd be incorrect. It goes all the way to the left, -5, all the way to the right, 0. That's my domain restriction. Last one over here, domain is all the x's such that we always eat to our right. This one on the left represents how far left. We can use this highlighter. 1, 2, 3. It goes to the left, -4. And since it is filled in, we know we can include it. So there is a line underneath. This one represents how far to the right it goes. Again, you can use a highlighter. 1, 2, 3, 4 to the right. And since it's filled in at the end, we know that it does include 4. Let's move on to the range. The range tends to be a little bit trickier because the range is not left to right, it's up to down. We still do the same concept though. All the y's such that we always eat to our right. Again, the opening is on the right, the opening is on the right. Now this is not left and right, this is low to high. Left to right, low to high. Left to right, low to high. Left to right, low to high. It's low to high because the range is down and up. So again, we can use a highlighter. And look at this one. How far down does this one go? Well, there's no restriction because eventually it's going down forever. I can erase my low end. How high does it go? Again, no restriction, so I can erase that and all the y's such that it's just y. This next one. The range is all the y's such that we always eat to our right. This is low to high, low to high. How low does this go? Again, no restriction. So we're running into a lot where there's not a lot of restrictions. There's no restriction down. How high does it go? Again, no restriction. It goes forever, so we're going to close this up again. Low to high, no restriction. It's all the y's, all of the real numbers. Range, all the y's, such that we always eat to our right. This is low to high. Now we can actually think a little bit, finally. How low does this graph go? We can use this highlighter. It goes down to -1. Is it included? Is it not included? We know for sure it's not included because it's an open circle. So it goes down to -1. Low. How high does it go? Low to high. Well, the highest, we can draw another restriction, is 1, 2, 3, 4. The highest it goes is 4. We know there's not a line underneath because, again, it's an open circle. So it's the range is all the y's as long as such that y is between -1 and +4. Last example we'll do over here. Range is all the y's such that we always eat to our right. This is not left to right, it's low to high. How low does it go? 1, 2, looks like -3. And it is included, I know it's included because it's filled in circles down there. I only need one of them, but it's a filled in circle. How high does it go? 1, 2, 3, 4. The highest it goes is +4. And you can include it, you don't have to include it. Whatever you put, we're not quite sure if it touches, it comes close. Let's include it for now, since we are going to touch that. That's one of the restrictions on domain and range. Remember, domain is left to right, left to right, left to right. Range is low to high, low to high. We always eat to our right in all of the cases. These next questions ask us to graph the function given the domain with a given domain using the table of values. The domain is all the real numbers. So in other words, whatever x's you want to use. What x's do we generally plug in? -2, -1, 0, 1, and 2. Those are the best ones. So I can plug in -2, -1, 0, 1, and 2. And then how do I find my y? I simply plug in. I plug in just like we've done before. Y equals 4 times -2 plus 3, which is -8 plus 3, or -5. I'll do the same thing. Y equals 4 times -1 plus 3, which is -4 plus 3, or -1. Plug in y equals 4 times 0 plus 3, which is 0 plus 3, or 3. I would continue plugging in. What it's actually going to end up being is 7 and 11. Now that I have those values plugged in there, I'll graph this. Probably should work on labeling x and y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. 1, 2, 3, 4, -5. All right, so it's -2, -5, -1, -1, 0, 3, 1, 7, and 2, 7, 8, 9, 10, 11. Now it's not just the dots. If you just plot these 5 dots, it's incorrect. It's the line that goes through those 5 dots. That's my equation. Let's do the same one over here. Let's plug in. Y equals -1/2 x minus 1. Well, my x is -2 for the first one, minus 1. -1/2 times -2 is +1 minus 1. Again, half of 2 is 1, and a negative times negative is a positive. This is 1 minus 1, or 0. Now, -1 is actually not a good choice. The reason I wouldn't want to do -1 is because -1/2 times 1 is 0.5. And then we got decimals, it's a whole big thing. So instead of doing -1, I'm actually going to choose -4, because I can take half of an even number. I'll do +4 down there. So -1/2 times -4 minus 1. It's going to make things a little wonky, but try to stick with me. -1/2 times 4 is +2 minus 1, which is 1. Then we plug in 0. Y equals 1/2. -1/2 of 0 minus 1. Well, half of 0 is 0 minus 1, which is -1. If I do y equals -1/2 of 4 minus 1, -1/2 of 4 is -2 minus 1, which is keep, change, -3. If I do the same thing with -2, I end up with -2 plus -1, -2. Let me plot these 5 points, quickly label. Now you have to be careful. When you find these points, you don't have to draw the line in the order in which you draw the dots. Just draw all 5 dots and then make your perfectly straight line going in order. That's -2, up, down, 0. -4, up, 1. 0, down, 1. To the right, 4, down, 1, 2, 3. And to the right, 2, down, 2. So if you look, it's a perfect line. You don't have to go all over the place based on what you got there. This is my nice straight line, just like that. So draw your line based on the dots in order going from left to right. That's what I did here. Left to right. That's the line, left to right. That's my line. Question 6. Question 6 asks us to go over the second way that we learned how to graph lines this unit, which is using the effect find the x and y intercepts. The x-intercept means that y equals 0. The y-intercept means that x equals 0. So it's as simple as if the x-intercept is, look for the x-intercept, I plug in y is 0, 3x minus 2y equals 12. If y is 0, I plug in 0, 3x minus 2 times 0 equals 12. Well, 2 times 0 just cancels, so I have 3x equals 12. That's a quicker way to do it. Divide by 3, divide by 3. X equals 4, or really 4 comma 0. Y is 0, you put 0 for y. Now y-intercept is the exact same thing, except I can just take 3x minus 2y equals 12, and if x is 0, that means this term goes away, and it's negative 2y. Don't forget it's negative 2y. Divide by -2, divide by -2, y equals -6, or really 0 comma -6. A lot of students get that wrong because they forget that the y is still a negative. And they don't get a -6. All right, so here are my two x and y intercepts, which is 4, 0, 1, 2, 3, 4, 0, and 0, 1, 2, 3, 4, 5, 6. So your line should look like that. The second example, 4x minus y equals -8. Again, the x-intercept means y is 0, so if y is 0, this goes away. Divide by 4, divide by 4. It looks like x equals -2, or really -2 comma 0. To find the y-intercept, 4x minus y equals -8, that means y-intercept means x is 0. This goes away, so it's a negative y equals -8. Now y, negative y, or really -1y, divided by -1, divided by -1y equals 8, or really again 0 comma 8. So -2 up, down, 0 is that one, and 0, 1, 2, 3, 4, 5, 6, 7, 8. Draw your line. Some students only put the dots when I do x and y intercepts. It's a line. You're getting just the point, you're only grabbing your line based on 2 points instead of based on 5 points, which is what we do with the table. Now, this one's a little bit trickier. Y equals -3/4 x plus 3, and that's why we need to know both strategies. The x-intercept means that y equals 0. So instead of y, I put 0. 0 equals -3/4 x plus 3. Now I got some solving to do. minus 3. Move over here. -3 equals -3/4 x. How do I get rid of this fraction? Well, I multiply by the reciprocal, which is -4/3. Still negative. -4/3 times -4/3. That all cancels, and I get x equals this. Well, let's do this. -4 times -3 is +12. 3 times 1 is 3, so the answer is 4. X equals 4. Really, 4 comma 0. As hard as the x-intercept was, the y-intercept is even easier. The y-intercept means that x equals 0. So instead of x, I put 0. Well, that is times 0. This whole thing goes away, and so y is just 3. So it's 0 comma 3. 0, 1, 2, 3, and to the right 1, 2, 3, 4, up, down, 0. Again, you're making one line based on those 2 points, not a vertical line, a horizontal line. It just looks like that. Number 7 is to complete the table for the function f of x equals 4x plus 1. F of x equals 4x, minus 1. Now, if we know x is -1, instead of x, we're reverse the x, we put -1. It's -4 minus 1, keep, change, that's -5. Again, we do the same thing, except now x is 0. Equals 4 times 0 minus 1, which is 0 minus 1, or keep, change, negative 1. While we're in the habit of doing it, we might as well do f of 3, because x is now 3, which is 4 times 3 minus 1, or 12 minus 1, which is 11. So how are these different? Well, these are different. We still take our function, f of x equals 4x minus 1. The difference is, it's not saying what x is, it's saying what f of x is. It's saying f of x is 0. So instead of f of x, the whole thing we put 0. It's essentially asking you to solve. F of x is 0. In this case, f of x will be 7. So I'm going to do another one in a little bit. F of x equals 4x minus 1, but instead of f of x, I put 7. So let's do this one first. Solve for x. That's what we're looking for. What is x? Solve for x. Plus 1 plus 1. 4x equals 1. Divide by 4, divide by 4. It looks like x equals 1/4. Let's do this one. F of x is really 7, so instead of f of x, I put 7 plus 1 plus 1. 4x equals 8. Divide by 4, divide by 4. X equals 2. So if x were 2, when I plugged in 2, I would get 7 out of it. Number 8 is very similar to number 7, except almost a little more straightforward. It's just telling you to evaluate for A, evaluate for B, and evaluate with C with a little bit extra for C. So let me get rid of some of this mess on the side, so I have enough space to do some of these problems. A. F of x equals negative 5x plus 4. First, we're finding f of 1. So everywhere where I see x, I put 1, which is negative 5 plus 4, or negative 1. F of negative 3 is negative 5 times negative 3 plus 4, which is positive 15 plus 4, 19. And f of 0 is negative 5 times 0 plus 4, which is 0 plus 4, or 4. For B, it's now g of x equals 3/4 x minus 7. So g of 0 first. 3/4 times 0 minus 7 is 0 minus 7, or negative 7. G of 4 is 3/4 times 4 minus 7. Well, 3/4 times 4, okay, I should have a calculator for this, but if you're not sure, it's 3 minus 7, which is keep, change, negative 4. Now I'll do g of 8 down here, because we're out of space. G of negative 8 equals 3/4 times negative 8 minus 7. 3/4 times negative 8 is negative 6 minus 7, which is keep, change, negative 13. And the last one, h of x equals 3x plus 9. So h of negative 1/3 equals 3 times negative 1/3 plus 9. 3 times negative 1/3 is negative 1 plus 9, which is positive 8. Next is h of, 0, which is 3 times 0 plus 9, which is 0 plus 9, or 9. And then h of 9 equals 3 times 9 plus 9, which is 27 plus 9, or 36. The only difference what that they need us to do is this last part, is find the 0 of x. In other words, the x-intercept. I'll do that one, and we'll do the pink. Find the 0 means if we take this equation, h of x equals 3x plus 9, the 0 of h means that this is 0. It means that h of x is 0. It's essentially finding what x gives us a value of 0 in the end. It's not saying plug in 0 again. No, no, no. We already did that. It's saying what x would give us 0. So instead of h of x, we put 0. Now we're going to solve for x. Minus 9 minus 9. 3x equals negative 9. Divide by 3, divide by 3. X equals negative 3. So the 0 is negative 3 because negative 3 is the number that when I plug in negative 3 into x, it would give me a result of 0. So this is called a 0. Negative 3 is called a 0 because that would give us 0 in the end. Speaking of which, these questions are asking us for the zeros. Find the zeros. In other words, what value would give us 0? What x, when I plug it in, would give us 0? Well, the way to find that is just make f of x 0 and then solve. Minus 16 minus 16. 4x equals negative 16 divided by 4 divided by 4. Looks like x equals negative 4. If I plug negative 4 in, it would give us 0. If you don't believe me, let me plug in negative 4. This is negative 16 plus 16, which is 0. So again, negative 4 is the value that would give us 0 at the end. Here's another one. 0 equals 2/3 x minus 10. Add 10, add 10. 10 equals 2/3 x. Multiply by the reciprocal 3 over 2. Multiply by the reciprocal 3 over 2. X equals, which is 3 times 10, which is 30, over 2 times 1, which is 2. So it's 30 divided by 2, or 15. 15 is the number that if I plugged it in, it would yield a number, a result of 0. 10. Look at this graph. What are the coordinates of A and B? Now it's tricky because there's no numbers written down here. You're not supposed to approximate. So you look at this graph and you think, how am I going to figure out what these are? And then you realize down here are the domain restrictions. So in other words, the x's, we know that this is left to right. So that goes all the way to the left, negative 5. We know it goes all the way to the right, positive 5. So I know my x values. This is negative 5 comma something, and this is 5 comma something. We're not approximating. This says left to right. Similarly, down here, this says low to high. Not left to right, low to high. So the low, this goes down. The lowest it is 4. Because the lowest is 4. This is negative 5 comma 4. The highest it goes, it says is 6. So this is to the right 5, up 6. So coordinate A, as you can see here, is 5 comma 6, and coordinate B is negative 5 comma 4. Use all the information that was given to you. Make sure you scan the entire thing. In this case, the important information was down there. Number 11 says a representation of a function is shown. F of x equals negative 3x plus 6. What are the x and y intercepts? Now we know the x-intercept means that y equals 0, and the y-intercept means that x equals 0. That's certainly easy. F of x equals negative 3x plus 6. So if x is 0, instead of x, I just put 0, which is negative 3 times 0 plus 6. Of course, negative 3 times 0 is 0 plus 6, or 6. So the y-intercept is 0 comma 6. Again, x is 0, y is 6. But then this one says, well, the x-intercept means y is 0. I don't see y anywhere. And then you remember f of x is a fancy way of saying y. So instead of f of x equals negative 3x plus 6, this is really y equals negative 3x plus 6. If that's the case, that means it's 0 equals negative 3x plus 6, because to find the x-intercept, y is 0. Now I solve for x, minus 6 minus 6. Negative 3x equals negative 6, divided by negative 3, divided by negative 3, x equals positive 2, or really 2 comma 0. Write it as a coordinate. And then number 12, there's another question. Talk about functions review. Choose all the ordered pairs that if we added them, it would allow it to remain a function. If you look, this is currently a function because negative 2, negative 1, 0, 1, and 2 are all different numbers. It does not matter about the y's. The y's don't matter at all. The range doesn't matter. So let's look. If I added 3, 5, would that duplicate any domain member? No, it would not duplicate, so it's good to go. If I put 2 comma 4, would it duplicate? Yeah, it would duplicate right here, so we cannot use that one. 4 comma 1, can I use that? Yep, I wouldn't duplicate with anything else, so that one's good to go. If I plug in 0, 6, no, we already have a 0. Sorry, buddy. Can't have more than one of those. 5 comma 0, again, we don't have a 5, so that's good to go. Negative 2, already got one. Sorry, you are out. Again, functions, each x has exactly one y. Can't have two x's, that same x showing up because that's going to go to two different y's.